and welcome to the shop. I've just been having a look through some of the vintage junk box components. I thought I'd get some parts together, build a transmitter, get it working and on the air. So this is the result. It's a vintage 1-valve power oscillator transmitter. It uses the classic 807 tetrode valve. As you can see, there's lots of beautifully exposed lethal high voltage points all over. This was a typical sort of construction from the 1930s, where amateurs would build transmitters and pin them out on breadboards or pieces of wood with little regard for health and safety. The 807 valve was first produced in the mid-1930s. I've tried to use as many vintage parts as possible. However, I've had to cheat a little bit. For example, in the power supply I'm using a solid state rectifier, and we're using some much more modern components here. The milliamp meter is dated 1943. Sometimes you've just got to use whatever you've got to hand in the junk box. Just taking a closer look at the transmitter. The mains comes in here, 240 volts AC, which goes through a fuse and then to the primary of a HT center tap transformer. I've got the center tap grounded. I'm taking wires from both the 350 volt secondaries, which go through the independent fuses, and then to 4.7 ohm wire wound resistors to reduce the inrush current to the rectifier diodes. We're using the beefier diodes, the 1N5406. They're both rated at 1 kilovolt. Both these electrolytics are the reservoir capacitors. They were both rated at 500 volts, which is too low, and 125 microfarads, which was a little bit on the high side. So I've wired them both in series, which halves the capacitance and doubles the working voltage to 1000 volts. The HT then goes to a 7 Henry choke, and on the other side, same arrangement, to 125 microfarad capacitors at 500 volts, both wired in series. I've put 100k resistors across the capacitors to balance the voltage across the terminals. The HT DC voltage then goes through a milliamp meter, which measures the anode current. So the high voltage DC comes into the transmitter via this 2.5 millihenry choke, and it goes up the wire through a parasitic suppressor to the anode. We've got about 525 volts going to the anode, so the RF would pass down here. It's blocked off by the RF choke. We've got a DC blocking capacitor, which is rated at 3 kilovolts, so the RF would pass through this capacitor and energize the tank coil, this pi tank network. This is a variable capacitor to tune the anode of the valve, and this capacitor would tune the antenna load. This RF choke here is a safety device. Should this DC blocking capacitor fail, the coil would be energized with the 525 volts, which will also be present on the antenna output. So the high voltage DC would be shunted down to earth and blow the fuses. The coil can be adjusted for different bands via the clip. We'll just go to the different tops of the coil. Down here we've got a grid choke, which blocks the RF going down to ground. The transmitter is crystal controlled via plug-in crystals. I was going to use these old style crystals, the larger ones, or maybe the popular FT243 crystals. However, I decided to use the HC6U crystals, as I've got a big stock of about 40 throughout the 80-meter band, from 3579 to 3790, so it made more sense to use the HC6U crystals. I'll give you a quick demonstration. I'll just plug the mains in. As you can see, I've got an indicator bulb, just as a reminder to keep the hands out, because the circuit is energized with a high voltage. We're running into a dummy load via the antenna tuner. And over here we've got the trusty old ICOM IC R71E receiver on standby. It's had time to warm up now, should be ready. I'm getting about 15 watts out. Quite a nice sounding tone, and it's rock solid with being crystal controlled. I found a couple of more 807s in the junk box. They will do as spares. The one I'm using at the moment is the Raytheon, made in the USA. It has a slightly larger glass envelope. So that's it for the moment. A 1-valve power oscillator transmitter. Thanks for watching the video. I hope to work you on the air, and I'll leave you with the schematic diagrams.